Hello and welcome, friends. Welcome back to another session on Quant, and what we are covering now is algebra. So, in the previous session, if you have seen the graph that we have started, one session before the last session, we started with graph fundamentals. In the last session, we talk about all the entry level or the foundational level problems of graph, where we understood how to apply the things that you have learned in graph fundamental into some of the problems, and we tried some of the defined problem statements, not absolutely easy ones, but also some little nuanced ones. So this is the second session of graph. So this is the second session of graph problem 2, and like you all know, we generally cover every topic in 1+2 format. One is basically the fundamentals, and the +2 are basically two problem sessions, where the first problem session is more targeted towards foundational or entry level problems, or ensure your understanding is absolutely clear. We also do some of the nuanced problems, but the problem session 2 is typically focused on advanced or more complex level problems that are has a higher probability to come in CAT, XAT, IIFT kind of exam. But having said that, the like I said, the earlier session or the problem session 1 also has a lot of problem which has come in CAT earlier. So there is no way to say that there is the problems are not relevant to CAT in problem session 1. They are highly relevant, but they are relatively simpler, so that your understanding gets more and more strengthened, and then you come to problem session 2. So if you have not gone through those first two sessions on graph, please go through that. I'll put the link in the description box. And today we will talk about 5 to 6 problems which are little nuanced from the graph standpoint, or around 6 to 7 problems are there. Okay, with that, let's get started. Okay. Like I always say, if you and if you are in this channel for the first time, if you are seeing a problem, don't continue to see the solution. Take 2 minutes, try to solve the problem, and if you are unable to, come and see the solution. And if even if you are able to solve the problem, please come back and see whether you have done it right, or whether the approach is there any better approach to do it. So, but before continuing to the solution, take your time, just try to solve the problem by your own for 2 to 3 minutes, and then come back and watch the video. So what's the solution? Okay, now let's see what it says. It says draw the graph of fx equal to 1 by x, and everything is variation of 1 by x. So the first one is 1 by x, second one is minus 1 by x, third one is mod of 1 by x. So first I need to identify what is the graph of 1 by x. Now if you see, now, if I say if x is equal to 1 by x, now I surely can say x cannot be equal to 0. X cannot be equal to 0. So x can be both positive or negative for this. Now, if you see 1 by x and x, let's see how the behavior goes. So I know, let's say if x is 2, 1 by x is 0 0.5, x is 3, 1 by x is 0 0.33. Similarly, if I say x is 4, 1 by x is 0 0.25, by 5, 0 0.2. So if you see these numbers, 0 0.5 to 0 0.33, the number is reducing slowly. The 1 by x value is reducing slowly. Here, 0 0.5 to 0 0.33, it has reduced by 0.16 or 0.17. Then it has reduced by 0.08. Now here it has reduced by 0.05. So the idea is the rate of reduce started getting slower and slower if you increase the value of x. And I say that similarly, if you check with 6, it will become 0 0.16. So if you see, the rate of change started getting slower and slower. But if you do the ulta, if you do say between 0 to 1, so basically between 0 to 1, what happens? So if I say 1 by x and x, so let's say 0 0.2, what will be your x? X is 0.5, right? If I say 0 0.3, What will be the value of x? Value of x will be 3.33. If I say 0.4, the value of x is 2.5, right? 2.5. If I say 0.5, the value of x is 2. So here I'm saying again from 0.2, so from 0.5 to 0.25, getting more closer to the 0. Understand this carefully. Here I am going farther from 0. So this is farther from 0. And this is closer to 0. So if I am going farther from 0, my values are increasing on the top. Farther from 0 means further beyond 1. Right? Beyond 1, if I'm going, my values are getting decreased. If I going more than 1, further from 1, not 0, let's say further from 1. If I say closer to 0 from 1. So if I'm going further from 1, my values are uh, decreasing slowly. The rate of change is slow. But if I'm moving from 1 to 0, let's say 0.5, then 0.4, 0.3, 0.2, my rate is increasing more because 0.5 it was 2, then 2.5, 0.5 increase, then it is more 3.33, 0.83 increase, then it's more than 1 increase. So you understand, if I'm going further towards 0, my values started shooting up. But if I'm going further away from 1, my values started slowly coming down. So how to see it in a graph? So the graph will be like this. The graph will be, so if this is x equal to 1, so if I go from 1, the values will be slowly reducing. After 1 towards, the more I go closer to the 0, the values started shooting up, right? It cannot be equal to 0, but yeah, that's how it is. This is 1, right? So to understand this, but here only I assume x as a x as a positive number, but there is also a possibility of, just a minute. There is also a possibility of x being a negative number. So again, the rule will remain same, but just the values of y will be negative for all the x negative. So if x is less than 0, your fx will also be less than 0. So it will follow this, right? So similarly, how you did here, so it will be in first quadrant because x positive to fx positive, x negative to, so fx is also negative. If it's negative and x negative, it comes to the third quadrant. So basically, if your x and y both are negative, it will come to the third quadrant and follows the same approach. If you go away from -1, then the values started slowly reducing. Similarly, if you go from -1 to 0, the more you approach to the 0, values started shooting up rapidly. So I could have drawn the graph right away, but I choose to explain. If you understand how a graph is formed, you will be easily able to do these problems, right? So always you can't remember the graph of a particular function right away. You have to think on your head and see, put some values, try to see what's the trend, and then draw the graph. So this is one of those examples. So okay, now let's do the last second problem. So I'm just going to remove this. So what will happen if it is fx equal to -1 by x? -1 by x means if x is greater than 0, your fx is less than 0, right? And similarly, if x is less than 0, your fx is going to be greater than 0, right? So the same graph, it will, the numbers or the nature of the numbers between fx and x will not change. So if I have x are greater than 0, my y's are less than 0. Uh, so this section will keep coming down like this. So this is at 1. So this top part, instead of going up, it will come to the, because x positive, y negative. So in this case, x positive, y negative. So it will be in the fourth quadrant. Similarly, in this case, x negative, y positive. So it will be in the second quadrant. So this section will be shifted towards like this, right? This is the graph of minus 1 by x. So this is fx equal to minus 1 by x. Understood? So how fx equal to 1 by x change to fx equal to gx equal to minus 1 by x. So this is not fx, this is basically gx in this case, right? So it's clear. If any part is unclear, please drop a note in the comment section. I'll be able to respond. Okay. Now, the last part is on hx equal to 1 by x. So now if I have hx equal to mod of 1 by x, what will change? It will change from here. There will be no negative part. So there will be no value. X can be negative, but for that y will be positive. So if I do this, so if your y is equal to mod of 1 by x, so x can take positive or negative, but y will always be positive. So it will behave. So when x is greater than 0, it will behave the same way like the one here. So it will be like this. Similarly, when x is negative, your y will no longer be negative. So this graph, so this section, y will be positive. So x can be negative, but y will be positive. This is 1, this is minus 1. This is the graph of hx equal to mod of 1 by x. Right? So you understood how you understood how to form a graph for the equations, for the expressions you don't know the graph right away. Then you know, even if you know the base graph like 1 by x, then how to change it for minus 1 by x, how to change it for mod of 1 by x. So you know the nuances of deriving particular type of graph or an enhancements of a particular base graph. So base graph here is 1 by x, and I change that to minus 1 by x. I see how it will change. Then I will change to mod of 1 by x. I will see how it will change to mod of 1 by x, right? So that part is clear. Let's move to the next problem quickly. It says find the area of the region bounded mod of x plus 2, mod of x plus 4, and x-axis. So again, understand what is the base. The base is y equal to mod x, is the base graph. So the base graph, if you remember, this is the graph of y equal to mod x. Now, how the graph will look like for mod x plus 2? Now we told if you add something within the mod, the graph will shift to the left. We call your fundamental class or some problem we did in the previous session, because it will shift to the left. Why it will shift to the left? Because if I, instead of here when x was 0, y was 0. Here y is 0 only when x is minus 2. So this entire graph will be shifted to the left, right? So this will happen. This is minus 2 comma 0. Then what is the next one? Gx equal to x plus 4. Similarly, there is another graph. There is another graph which will be shifted. Yes, this is mod of x plus 4, and this is mod of x plus 2. Right? So these are the two graphs and the x-axis. So x-axis is this anyway, this one. So what would be the region? The region is this region. What will be the area bounded by this region? So this is minus 2, 0. This is minus 4 comma 0. Okay. So region, let's say this point is A, this point is B, and this point is C. So triangle ABC is basically half into the base is AB into height. So what is the base? So the AB is 2, half into 2. So minus 2 to minus 4. So this distance is 2 only. This distance is 2. And where they intersect each other, we just need to find out, right? So where these 2 points will intersect each other. So this side, it is x plus 4, where it should be equal to not of x plus 2, because this line, if you see this line carefully, this line is not of x plus 2. This is minus of x plus 2, right? So minus of x. So I know the red line is x plus 4 positive 9, but the uh, green line of x plus 2 is basically minus x minus 2, right? So here 2x is equal to minus 6 or x is equal to minus 3. So this point x is equal to minus 3. At x equal to minus 3, your both of this line, your y is equal to 1, sorry, minus 1. Yeah? At x equal to minus 3, y will be equal to minus 1, right? Just let me see whether I'm doing it right. Minus and minus 2, no, sorry, plus 1. Y will be plus 1. Yeah, that's what I was looking for. X is equal to minus 3, then y will be 1. So this point, if you see typically, it is minus 3 comma 1. So the height, I can say it's of 1 unit because the y value is 1. And so 2 into 1, so this is 1 square unit. That's the answer. Okay. So first, two things here we learned. One is how to shift the base graph to the left when it is plus sign into the modulus. Then we identify the common area, and then we say how to identify the cross-section region. The most important part is it is not x plus 4 equal to x plus 2. See, this is the line. This is the line. This is the line that determines x plus 4 as a positive number. This red is the line that determines minus of x plus 4 as a number. Similarly, if we say this line says minus of x plus 2 as a number, and this line determines plus of x plus 2 as a number. Together, it will be mod of x plus 2. But the negative part is of a minus of x plus 2. So when two lines are intersecting, the plus x plus 4 is intersecting with minus of x plus 2. It's not x plus 4 intersecting with x plus 2, right? So if you remember the mods class, what we did, we said y equal to mod x is x can be positive or x can be negative. For both of which y will be positive, but y can be equal to x, y can say equal to x, or y can say equal to minus x also, right? So that's what. So the minus part is what has gone to the left, and right part is what is gone to the right for both the lines. So when you equate, you see which line's right part is equating with which line's left part. The left part is typically the negative one. In this case, don't try to memorize this and try to apply generally. Always understand the problem first. So which side is the positive side, which side is the negative side. So when we draw a graph of y equal to mod x, this line typically denotes x greater than 0. This line typically denotes x less than 0. So if I know which side is greater than 0, which side is less than 0, I should apply the same in this case, right? So hope this is clear. Now let's move to the next problem. Okay. It says fx equal to max of 2x plus 1 and 3 minus 4x. So let's say 2x plus 1. How will be the graph? Understand this. So y, x. So when x is minus half, when x is minus half, y is 0. Say y equal to 2x plus 1. And yeah, when x is minus half, y is 0. And when x is 0, y is 1. Okay, that we got, and also we got when x is 1, y is 3. So let me just draw the graph. It will be a straight line. There is no negative or modulus there. This will be a part. But when x is minus half, when x is minus half, y 0, when x 0, y 1, right? So the line will go somewhere like this. The line will go somewhere like this, where this part, this this part is minus half comma 0. Oh, sorry, let me draw a little bigger. Okay. So let's see, this is the line. So this is, so this part is minus half comma 0, and this part is 0 comma 1, right? So this is the graph of y equal to 2x plus 1, right? Now the next graph is 3 minus 4x. So y equal to 3 minus 4x. So let's see what happens with y and x. So when x is 0, y is 3. When y is 0, or when y is 0, x is 3 by 4. So when x is 0, y is 3. This is a point. And when x is 0, y is 3. And when y is 0, when y is 0, x is 3 by 4. So this is, let's say, 3 by 4. This is the line. Graph will go like this. So this is 3 by 4 comma 0, and this is 0 comma 3. Okay. So this is what is the max point. So I can see the max point of both the line is only possible at the intersection, because above that both the lines are not included. So if you go x take here, it will be having x here. So that's the maximum point. So the minimum value of fx. So see, what I'm trying to say is, now if you see, now let me draw a simpler graph. So just reduce this. So the graph that looks like is this. So there is a line like this, and then there is a line like this, let's say. Okay. Now, what will be the minimum value of fx? Minimum value of fx means minimum of y. Fx is y. So minimum value of y is possible. See, when you take a take anything here, let's say you take a point here, the fx is just the maximum of these two. So for this is y equal to 2x plus 1, and this is y equal to 3 minus 4x. So if I take x as this point, my 2x plus 1 give me this point, and my 3 minus 4x gives me this point. So maximum between these 2 points, I have to take this point. Similarly, if I take x here, my 2x plus 1 gives me this point, and 3 minus 4x gives me this point. So I have to take this point. Similarly, if I go to the right, I take this one, my 2x plus 1 gives me this point, and 3 minus 4x gives me this point. So my maximum point is this. So if you see this typically, your maximum points are always higher. It is minimum only when it is here at the intersection point. If you see carefully, in talking about, so the minimum value of y can only be achieved when the value of x is giving you the y, which is the intersection of these 2 points. So for this x, we can say this is the value of y. So this is the minimum of y possible, because y always takes the maximum value between the two lines, between the two expressions. And out of these two expressions, if I consider both, this intersection point is going to be the minimum. So if I have to do this, then what is the equation? So intersection point means it has to be equated. So 2x plus 1 must be equal to 3 minus 4x. So that is 6x is equal to 2, or x is 2x plus 1, 3 minus 4x. X is equal to 1/3. X is equal to 1/3. And if I put in this equation, your y, minimum of y, the minimum of y becomes 2 into 1/3 plus 1, or 2/3 plus 1, or 5/3. So 5/3 is the minimum value of fx. Y is fx, minimum value of fx is 5/3. You can put the same in 3 minus 4x. Instead, you can replace there also x as 1/3, you will get the same answer. So the idea here is to understand how to find the minimum of these two values, these two lines, the minimum of these two lines when you are equate these two lines, because the nature of these two lines always give maximum y, or always gives the maximum value of y, which is more than the intersection point. So at any point apart from this, here x is 1/3. At any point other than x equal to 1/3, you put your maximum value of y, maximum of these two function will always be more than 5/3. Okay, let's move on to the next problem. Now you see carefully, this is the difference one. They said fx is minimum of 2x plus 1, x plus 3, and 5 minus 2x. So what is 2x plus 1? If I say 2x plus 1, if I put y and x, so when x is 0, y is 1, and when y is 0, x is minus half. So if I have to put it in a graph, x is 0, y is 1, x is minus half, y is 0. So the line will go like this. So this is 2x plus 1, right? Now the next one is y equal to x plus 3. X plus 3. So in that case, if I put y and x, x is 0, y is 3, y is 0, x is minus 3. So x is 0, y is 3. So this is 1 point. And when y is 0, x is minus 3. This is another point. So if I draw this line, just a minute. So when I draw this line, this is minus 3. Okay, this will go a little far. Just a minute. Let me just work this. So this will go. Sorry. So if you see this, what I'm trying to say is if this is minus half, this point is minus half. So 3 will be somewhere a little further. And this point is 1. So we can say 3 will be somewhere here. So just for the sake of the scale, I'm just taking it. Let's say the line will be like this. So you have a red line, you can go like this. Okay, so these are the two lines. So here it is basically minus 3 comma 0, and this is 0 comma 3, and this is 0 comma 1, and this is minus half comma 0. Right, so you got this two. Now the next one is y equal to 5 minus 2x. Now if I see this carefully, y by x, so x is 0 when y is 5, then when y is 0, x is 2.5. So when x is 0, y is 5, so let's say somewhere here, and when y is 0, x is 2.5, so this is somewhere here. The line We'll go like this. So let's say this is 2.5. Okay. So this is 2.5 comma 0 and this is 0 comma 5, right? So these are the three lines you have, right? Now what they said, find the maximum of fx which takes the minimum of these three values. So minimum of these three values. So if you see typically here, what I say is here, if I take x, obviously it will be here, this will be a value, bottom there will be a value, and top also there will be a value, but the minimum value will be this point. Now if I take x equal to this, if I take x equal to this, let's say the intersection points, if I take x equal to this will be the intersection point between 2x plus 1. This point will be the intersection point between 2x plus 1 and 5 minus 2x. Similarly, this will be the intersection point between 2x plus 1 and x plus 3. 2x plus 1 and plus 3. So the red line, denotes x plus 3 and the green line denotes 5 minus 2x. So from the previous one, I understood somewhere will be there are three intersection points, and somewhere in this three intersection point lies the minimum, right? So let's see what are the different intersection points we have. So first, if we equate 2x plus 1 is equal to x plus 3, we get x equal to 2. Okay. If I put x equal to 2, your fx becomes what are the minimum of 2x plus 1 becomes x equal to 2 means 5, x plus 3 means 5, 5 minus 2x is 1. So minimum of this, that means 1. Now let's equate 2x plus 1 with 5 minus 2x. So this point basically. So 2x plus 1 is equal to 5 minus 2x. So 4x is equal to 4 or x is equal to 1. So then fx will be minimum of what all? If x is equal to 1, this is 3, this is 4, and this is 3. So minimum, so here fx will be 3, right? Now the last part is if I consider 5 minus 2x is equal to x plus 3. So 5 minus 2x is which line? The green line. And x plus 3 is which line? The red line. The green line and red line cuts here. So this is the point I'm looking for. So here your 3x is equal to 2. So x is equal to 2 by 3. 3x is equal to 2. So x is equal to 2 by 3. Now if x is equal to 2 by 3, my fx will become minimum of what all? So if it is 2 by 3, the first one, 2 into 2 by 3x, so 4 by 3 plus 1. So 2 into 2 by 3 plus 1, or 4 by 3 plus 1, or 7 by 3, or say 2.33. So the first value is 2.33. What is the second value? The second value says it is x plus 3. So x plus 3, what is my x? X is 2 by 3. 2 by 3 plus 1 by 3 is how much? 5 by 3. So this is 1.66. 5 by 3 is 1.66. And the last one is also going to be 2 by 2.33. Oh, sorry, last one is also going to be 1.66 because the last two only I have considered for fx as a so 5 minus 2x is equated with x plus 3. So both of these will give you the same value. So the minimum value here is 1.66, this one. So I can say the x equal to 1 is the minimum, where x equal to 1 is the value where fx is going to be maximum. So maximum of fx is 3. maximum of fx is 3. What is x equal to 1? When x is equal to 1, when 2x plus 1 is equal to 5 minus 2x. 2x plus 1 is the red line, and 5 minus 2x is the 2x plus 1 is the black line, and 5 minus 2x is the green line. So the black line and the green line. So this is where I'll get the maximum of fx. Now you might say this point is more, but this point is just the intersection. So for this point, I will get y value as at this intersection, but x value at here, right? So x value somewhere on the so for think of this, for two lines, I will get y value at the red and green junction, but for those same x, which gives me that red and green intersection point of y. So that point, for that x, I will have y on the red line below that. So it will, the minimum of all these three will be the on lying on the black line and not on the junction. But if you see this junction typically, let me just show you this. If you see this junction typically, this one, then you see the green and the black line cuts at this junction. But for even for this junction, this is the minimum, and the line that is not intersecting the red is above this. So above this means it will be more. So obviously, when I do a minimum function, I will still get this point, the junction. So this junction is going to give you the point where x is 1 and y is 3, and y is your maximum of fx. That's how you can do it. So if there are more than two entities, you just equate and see where you get maximum, and this is further validated by the graph, right? So let's move on to the next problem. This is sketch the graph of y equal to x minus 4 when y is 0 and x is 6. So basically there is one line only. There is one line only. So x cannot go negative. So x minimum is 0, maximum is 10, and it's 6. So y equal to x minus 4. So y equal to x minus 4. So if I put y and x, so y at 0, so x at 0, y is minus 4, and x at 6, 6 is the, it is not 6, just less than 6, say 5.99 something, just assuming it's 6, y is 2. So this is the point. So when x is 0, y is, let's say, minus 4 at this point. And when y is 2, x is 6. So when x is 6, y is 2. So the point equation will go like this. So this is the point. So this is x minus 4. So this is the point where x is 6, y is 2. Okay. Now if you see carefully, this part will not exist, because y equal to x minus 4 only till x equal to 6, not beyond x equal to 6. So, and from there, we have another equation which says y equal to 8 minus x. So if I now plot this, y and x, so at x equal to 0, x equal to 0 is not possible basically because it starts from 6. So at x equal to 6, your y is 2, and at x equal to 10, 10 is the maximum. At x equal to 10, your y is minus 2. So here if I say 10 and this is minus 2, so this point is nothing but 10 comma minus 2, and this is the graph will come down like this. This is the point. The graph will come down like this, right? So this is the graph. So the maximum and minimum value of y in the given domain, right? So the maximum value of y from the graph, I can see this is the point. So the maximum value of y is 2, because the graph, the black line goes like this and then shifted towards down after 6. So that is the max, the max and minimum value of y. Max of y is equal to 2. And what is the minimum of y? See, minimum of y, obviously now you also know this lines will not exist. These lines will not exist because x cannot go less than 0, x cannot go more than 10, so these lines will not exist, right? These lines will not exist. So here I can see y value is -4 at the lowest point of x, and y value is -2 at the highest point of x. So the minimum value of y, minimum for y is -4. This is the minimum point. So compared to this point and this point, this point basically gives you some lower part. So this is basically nothing but your -4 comma 0. Sorry, my bad. It's 0 comma minus. So -4 is minimum and +2 is maximum. Okay. Hope this is clear. Moving to the next problem. Is the graph y equal to mod of x minus 7 mod of x 3 by 2. Now, if you see this carefully, this graph, it's a very interesting graph, right? Mod of x minus 7 minus mod of x minus 3. So again, if I just say y equal to mod of x minus 7 minus mod of x minus 3, you know your roots or zeros are typically at 3 and 7. Recall the basics of your graph and modulus, inequality modulus. So 3 and 7. So I want to see how, so basically then there are in a line, there are 3 zones, 3, 7. So this is beyond 3, within 3 to 7, and then this is after 7. So these are the 3 zones. So one is less than 3, one is 3 to 7, and another is greater than 7. So these are the 3 zones that is created. So how the graph will behave? So with less than 3, it will be y equal to minus of x minus 7 minus of x 3, or this will become plus. So basically both of them will be negative, less than 3. So this is minus x minus 7, obviously by 2, plus x minus 3. Okay, so here I can say y is equal to minus 10. X will get cancelled, obviously this by 2. So minus 10 by 2, minus 5. Right? So y is equal to minus 5 when it is less than minus 3. So between 3 to 7, what will happen is, between 3 to 7, x minus 3 will be positive and x minus 7 will be negative. So let's say between 3 to 7, what will happen is y equal to x minus 3 will be positive, x minus 7 will be negative. So minus x plus 7 minus x plus 3 by 2. Or we'll say minus 2x plus 10 by 2, or minus x plus 5, or we'll say 5 minus x, y equal to 5 minus x between 3 to 7. And what will happen greater than 7? Both of them are positive. So y will be equal to x minus 7 plus x minus 3. Sorry. So this is minus x minus 3 by 2. So x will get cancelled. So minus 4 by 2 or minus 2. So what I see, this entire thing breaks down into 3 parts. So y is equal to minus 5 when x is less than 3. Y is equal to 5 minus x when 3 less than x less than 7. and y is equal to -2 and x is greater than 7, right? So these are the three zones I can say. Obviously, you can include the equal to's also, but these are the three equation that is coming out of the part that is given x. Okay. Now with this three equation, let's see if I can draw a graph. Remove this part. These are my three equations. Now we try to draw a graph x less than 3. So this is x less than 3. So somewhere here, 3, 7. So above the less than 3, wherever x is less than 3, y is fixed at -5. So what is y? Y is at -5. So y value is fixed. So this will go continuously like this after 3. So if this is 3, this is 7, and let's say this is -5. So y will be flat when x is less than 3. And when x is more than 2, y will be -2. Right? So -2 means it will be flat somewhere here. It will be flat somewhere here. Wherever x is more than 3, then this is -2. So this point. So from 7 onwards, whatever value x takes, 8, 9, 10, y value will be flat at -2. Right? So from here to here, this line. If you put 5 minus x, so if I just put y equal to 5 minus x, so x is 0, then y is 5. Similarly, if you put x is 7, y is -2. This is the point. This is the point 7 comma -2, and this is the point 0 comma -1. So this is going to be the graph, and obviously it will not have this section. Sorry, we will not have this section. Okay, so the graph will be like this. Okay. Now x equal to y minus 7 and y minus 3 by 2. This will be the same thing happening for the x. So the same thing happening for the x, I can say clearly. Same thing happening for the x. So x will follow the way y is following. Now y will have a 3 and 7. So y, let's say this is 3, and let's say this is y as 7. So if y is less than 3, x is going to be -5. If y is less than 3, x is going to be -5. So x is going to be -5 means this side. So x is going to at this zone. And when y is more than 7, x is going to be -2. X is going to be -2 means going to be -2. So when y is more than 7, x is going to be -2. So this is the line. And we have to just join this two line. Right? This is in between. The same thing will be shifted for x. Right? Okay. Now, hope this is clear. So you understood how to do this kind of a problem. Let's see the last problem for today. It says, find the area enclosed by the region bounded by the relations 2x plus 3y less than 15, 3x plus 2y less than 15, x greater than 0, and y greater than equal to 0. So that means it has to be in the first quadrant. So let's see what is my 2x plus 3y less than equal to 15. Or let's say, even if I say equal to 15, what are the x and y? When x is 0, y is 5. When y is 0, x is 7.5. right? So this is one point, and the other one is 3x plus 2y equal to 15. In this, if I say when x is 5, y is 0, and when x is 0, y is 7.5, right? So if I have to draw the graph, the graph will be like this. It will always be in the first quadrant because of in the first quadrant only x is greater than equal to 0, y is greater than equal to 0. Both are greater than equal to 0 only in the first quadrant. Now, the first one says x0, y5, x0, y5. So this is a point 5 and x 7.5, 7.5. So this is one line. This is one line, and the other one is x5, y0. The other one is x5, y0, and x0, y 7.5. So this is another line. Okay. So this line is 3x plus 2y equal to 15. And you have this line, which is 2x plus 3y equal to 15. Okay. So that we got. Now what we need to figure out is the zone. Let's say A, B, C, D. This zone we need to figure out. C is this point. Okay. So if I have to shade it, this zone is what you need to figure out. Now, for the simplicity, I will just remove this dotted line. So if you see this line, okay, consider this y-axis is a straight line which does not look like. So I can break it into a trapezium. On trapezium, let's say this is E. Can I say trapezium A, B, D, E plus right angle triangle B, C, E? If I add these two, I will get the answer. Now for that, I need to know what is the, let's say if I know all the coordinates. So A, let's say A is 2x plus 3y equal to 5 at when x equal to 0. So A is 0, comma 5, right? What is D? D is 0, comma 0. What is C? C is 7.5, comma 0. Okay. And what is E? E and B should be, Y value should be same because from B I have dropped a perpendicular. So B is nothing but the intersection of these 2 points. So if I just calculate the intersection, so it says 3x plus 2y equal to 15 and 2x plus 3y equal to 15. So if I add both of them, what I'll get? I'll get 5x plus 5y equal to 15, or I will get x plus y equal to 3. If I get x plus y equal to 3, it is same as writing 3x plus 3y equal to 9. 3x plus 3y equal to 9. Now if you subtract 3x plus 3y equal to 9, just a minute, let me see if I got it right. X plus y equal to 3. Yeah. And 2x plus 3y is 5x plus 5y. Sorry, my bad. If I add all of them, 5x plus 5y becomes 30. So x plus y becomes 6. And that reminds me 3x plus 3y is equal to 18. So we just multiplied with 3. 3x plus 3y equal to 18. Now, if I do at 18, what will happen? 3x plus 3y equal to 18, 3x plus 2y equal to 15. So 3x plus 3y minus 3x plus 2y is equal to 18 minus 15. So this is 3x gets cancelled, y is equal to 3. Now if I put y equal to 3 in this equation, 3x plus 6 is equal to 15, or I get x is also equal to 3. So this intersection point is nothing but 3, 3. So E is nothing but 3, 0. Okay. So I got all these coordinates. Now I can easily calculate this one. So what is a trapezium? A trapezium is half into sum of perpendicular sides. Now perpendicular side is this and this. The perpendicular side in the first case is 5. In the next case it is 3. Into the height. Height is nothing but this, which is also 3. Plus the right angle triangle. So right angle triangle has the height of 3. Half into 3 into this distance between 3 and where C, the green line cuts the x-axis, the green line cuts the x-axis at 5, 0. So C is not 7.5, my bad. C is not 7.5. C is actually 5, 0. This point is basically 7.5, 0. C is 5, 0. So this point must be 2. So this point must be 2. Half into 3 into 2. So this is what you get. So 8 to the 24. So this is 12. 12 plus 3 or 15 square. Answer. So I hope this is clear. We now understood what is this and how we got this problem. So we first draw all the line, and also one important thing is this is 2x plus 3y less than equal to 2. Less than equal to 15 means it has to be on the inner side, and for the green side also it has to be from the inner side. So when it is like this, the less than shows which is lesser than this side towards the left, and the greater than shows towards the right. We call the basic inequality class. And if you have not gone through that, please go through that in the algebra playlist. I'll share in the description box. But that's how we will solve it. After you got the intersection zone, you just break it into a trapezium and a right angle triangle, and you solve it. Okay, so that's how we do it. Hope this session was helpful. We learned around a lot of problem around graph, and with this, I hope you will be able to understand graph well. Try to solve around 20-25 problems based on this class, or together we have covered around 15 problems from graph. At least try to solve 40-45 problems in graph. You will be able to master the graph completely. Any doubt, anything, please drop a comment, or you can drop me a mail in the mail ID given in the description box, and we can take it from there. But I do like, share, subscribe the video. If you see this is a value adding, value adding sessions that you are getting from me completely as free. So please feel free to subscribe to the channel. See you next time. Bye.